In Louisiana, crawfish are caught, cooked, cleaned, and of course consumed. Crawfish contribute to the economy through job opportunities, farm income, and wholesale and retail sales. Now through marketing campaigns, crawfish are being enjoyed outside of their traditional marketplace with the opportunity for further expansion. With all of this going for crawfish, it's time to celebrate Louisiana's culinary crustacean. Crawfish production is the largest crustacean aquaculture industry in North America and is located primarily in the southern U.S. The industry focuses raising the animals for human consumption, although some are sold as fish bait, for aquariums, or for research. But the bulk of the industry is geared toward producing food for people. The culture of crawfish evolved primarily in Louisiana, and that state continues to dominate the industry in both culture and capture fisheries, with total annual yields of about 80 million pounds. Crawfish are also grown in several other states, including Texas, Arkansas, Mississippi, and in both North and South Carolina. Two species of crawfish dominate the industry, the red swamp crawfish and the white river crawfish. They are often found together in commercial fishery and in culture ponds. The two species have similar ecological and cultural requirements and may be similar in appearance to inexperienced persons. Though the white river crawfish is often lighter in color, sometimes having a whitish appearance, color alone is an unreliable means for distinguishing them. Other key features of the white river species, such as longer, slender claws, lack of a dark pigmented stripe underneath the tail, and a wider gap where the two halves of the carapace meet, are better identifiers. The abundance of each species varies among ponds, however, the red swamp crawfish usually dominates and is preferred in the marketplace. Despite efforts to limit culture to the red swamp species, both are responsive to production methods. Crawfish aquaculture developed around an existing commercial fishery. Early immigrants took advantage of Louisiana's extensive wetlands to harvest game and fish and discovered that crawfish were excellent table fare. Crawfish thrive in the Mississippi floodplain of the Atchafalaya River Basin and are adapted to flooding and drying conditions common in this system. Their abundance and acceptance as a food source led to the commercial fishery industry. However, this fishery is seasonal and corresponds to extended periods of flooding. Harvest is highest in years when high water levels are sustained and low when water levels are low or floods short-lived. Farming practices began modestly in the 1950s. The industry became more commercialized in the 1960s when rice farmers and landowners began to expand with crawfish. Rice farmers have suitable flat land, much of the necessary equipment, and organic residue left over from the rice harvest. Crawfish was a logical choice for a second off-season crop. Because of expanding markets for crawfish and low profits for agronomic crops, land devoted to crawfish grew rapidly until the late 1980s, when it peaked at more than 130,000 acres in Louisiana. Most rice and crawfish farmers regard crawfish culture as a vital component of an integrated farming system. However, very few producers make their sole living on raising crawfish. The life cycle of the crawfish is well suited to fluctuating periods of flooding and drying. Sustained periods of flooding, either by nature or people, permit crawfish to feed, grow, and mature. Draining promotes the oxidation of bottom sediments, reduces aquatic predators, and allows for the establishment of vegetation which serves as cover for crawfish and food resources when flooded. Crawfish survive the dry intervals by digging burrows for moisture and to avoid predators. Crawfish have adapted to reproduce within the protection of the burrow. Mating occurs in open water, and the female stores sperm in a protective receptacle, usually until she retreats to the protection of the burrow to spawn several weeks later. Burrows are simple, nearly vertical tunnels 2 or 3 feet deep. Entrances are often marked by the characteristic chimney and are found slightly above the water on pond levees or associated with puddles under drying conditions. Burrows usually contain a single female or a male and a female. Burrowing occurs at any time of the year, but mostly beginning in late spring as crawfish mature and ponds are drained. Survival in the burrow depends primarily on moisture in the burrow and health of the animal. Immature crawfish and those forced to burrow by rapidly dropping water levels may construct shallow burrows that are ineffective at maintaining moisture for survival. Soil types with limited clay content or soil with very high clay content that cracks during severe drought may also limit crawfish survival. Although crawfish can survive in humidified conditions within the burrow, free water is necessary for reproduction. While ovarian and embryo development are temperature dependent, the incubation period is about 3 weeks at temperatures typical to the summer burrow. The number of offspring produced varies with the size and condition of the female. Large crawfish can have more than 500 young. Hatchlings are attached to the female through 2 moats and then remain with her for several weeks. The female and her young must leave the burrow within a reasonable time because little food is available in the burrows and females are known to cannibalize their young. Crawfish are confined until the hard plug that seals the burrow is softened by external moisture. Pond flooding in combination with heavy rainfall encourage crawfish to emerge. Brood females emerge with young or eggs attached to their abdomen. Hatchlings are separated from the females and become independent. Because reproduction is somewhat synchronized in pond-reared crawfish, ponds are flooded in autumn to coincide with the main period of hatching. However, the white river crawfish usually spawn only in early autumn, while the red swamp crawfish may reproduce at any time. Peak recruitment for the red swamp crawfish usually occurs in autumn, with subsequent minor waves of hatchlings throughout the year. This continuous recruitment leads to differential growth rates and a population of mixed sizes. Crawfish must moat or shed their hard exoskeleton to grow. The growth process involves periodic episodes of molting, with an intermolt period between each shedding incident. Molting is hormonally controlled and happens more frequently in younger animals. Frequent molting and rapid growth occur in ponds when temperatures are optimum, food resources are adequate, and crawfish are not overcrowded. Typically, harvest size is reached in 3 to 5 months. Both males and females molt to a sexually active stage and growth ceases. Sexually mature animals exhibit distinct characteristics such as darker coloration, enlarged claws, and fully developed sexual structures. Mature males develop prominent hooks at the base of the 3rd and 4th walking leg. The number of mature crawfish will increase as the temperatures of late spring increase. Females will mate after their maturity molt and begin the process of constructing burrows at the water's edge. Crawfish eat both plant and animal matter. Crawfish will consume plant material when no other food source is available. However, they get little nourishment from plant material alone. Decomposing plant material with its associated microorganisms called detritus is preferred and has a higher food value. Although crawfish can sustain themselves by eating detritus, the ability to use it as a main food source appears to be limited. For maximum growth, they must feed on high-energy seeds and the rich assortment of invertebrates and other high-protein sources available, such as worms, mollusks, and other crustaceans. The main role of the forage crop is to provide the fuel that drives the food chain, with crawfish at the top of the food chain. Because commercial production dictates high crawfish densities, and because the season is long, the food chain requires a forage crop that yields plant fragments consistently over the course of a season. Crawfish production requires an understanding of the natural life cycle processes, providing conditions that facilitate reproduction and growth, and a means to harvest. Current farming practices are based on annual hydrological cycles and conditions with little additional inputs. Flooding and draining mimics natural cycles, although the control achieved with aquaculture provides for the optimum conditions regarding timing and length of flood periods and a degree of control over water quality. Crawfish aquaculture relies on natural reproduction, so no hatcheries or nurseries are needed. Crawfish in commercial ponds depend on an available food web for nourishment. Supplemental feeding is not a common practice, nor has it been shown to be effective in increasing yield or harvest size. Crawfish farming follows 2 main approaches: monocropping, or single crop system, when only crawfish are harvested, or the second system is the multi-crop system, where rice grain is incorporated into the system along with crawfish. In some instances, another agronomic crop is incorporated. The multi-crop system can be further broken down into 2 different management types. There may be several variations within any of these systems, but the basic cultural requirements for producing crawfish are similar. In single crop systems, rice may be planted as a food resource, but grain is either not harvested or not produced because of the later planting date. This method is favored by small farms or where marginal cropland is being used. Permanent ponds or sites devoted to several consecutive years of production are used in this strategy. The main advantage is that producers can manage for maximum crawfish production without concerns associated with other crops such as pesticide exposure or seasonal limitations. Crawfish yields typically range from less than 200 pounds per acre in large low-input systems to more than 1,500 pounds in intensely managed ponds. Disadvantages of the single crop system include the need to construct ponds. In the multi-crop system, established rice fields serve this purpose. The cost of a single crop system is amortized to one crop only, and overcrowding usually occurs in several cycles, particularly in small ponds. These ponds often yield stunted crawfish that are difficult to market. Single crop farming begins with the construction of ponds that must be completed before early summer to allow the stocking of brood stock. Stocking typically occurs in late April through July. Because crawfish burrow into levees, major levee renovations after stocking can hurt production the following season. Ponds are drained several weeks after stocking and are prepared for the establishment of a forage crop. Native voluntary vegetation can sometimes be an effective resource and cheaper to establish, but it's unreliable and often insufficient for maximum crawfish production. Crops such as rice or sorghum Sudan grass have been the most effective forages for crawfish. Rice, however, is the preferred forage crop. Because of its semi-aquatic nature, it persists well in flooded fields and more consistently breaks down into basic food resources. Time of planting is probably the most important consideration in forage management. Farmers should plant early enough to maximize vegetative growth, but not so early that the plants reach full maturity. A crop that reaches full maturity before winter tends to become depleted prematurely. In Louisiana, the most appropriate time for planting ranges from late July to mid-August for rice and mid to late August for sorghum Sudan grass. The LSU Ag Center has developed the only rice variety specifically for use in single-crop ponds. Écrevisse, the French word for crawfish, was released in 2004 and possesses more of the desired traits for crawfish production than those varieties grown in commercial grain production. Écrevisse provides more forage biomass, better persistence under the extended flood conditions of a crawfish pond, and grows better after winter than other domestic varieties. Écrevisse is limited to single-crop crawfish systems because of its short grains and poor milling traits. While rice is more forgiving and typically easy to grow with adequate irrigation, sorghum Sudan grass may be more suitable where summer irrigation is not available or the optimum window for planting rice has passed. Sorghum Sudan grass grows fast, is drought-tolerant, and can be planted later than rice. Pond flooding can commence in September in rice fields and October where sorghum Sudan grass is established. Depending on growing conditions and crawfish density, harvesting may begin in early November in established ponds or as late as February or March in new ponds. Harvesting continues until the yield becomes so low that harvesting is no longer justified or is unprofitable. Not all of the crawfish are captured, so ponds typically do not have to be restocked. As crawfish mature, they will seek higher ground and retreat to burrows to survive the summer months and reproduce to populate the pond the following season. Usually ponds that remain in production for several years do not need to be restocked. Crop rotational systems that include crawfish involve rice harvesting or may include soybeans or another commodity in sequence. There are two different approaches to the co-culture of crawfish and rice. In both strategies, crawfish culture follows the harvest, and the forage crop for crawfish is derived from regrowth of rice stubble after grain harvest. Advantages of these double cropping strategies include efficient land use, labor, and farm equipment. Also, some fixed cost and the cost of rice establishment can be amortized over two or more crops instead of one. One approach is the rice-crawfish-rice rotation. This system takes advantage of the seasonality of each crop to obtain two crops in 1 year in the same field. Rice is grown and harvested during the summer with fields reflooded in early autumn. Late winter and early spring are devoted to harvesting crawfish. In late spring, ponds are drained and rice is planted to begin the cycle. This approach is similar to the single crop system in that stocking is needed only in new ponds. However, the harvest season is often cut short to facilitate the planting of the subsequent rice crop. This cropping approach is most difficult to manage because yields of crawfish and rice may suffer because of constraints of timing, pesticide use, and other issues. This type of crop rotation accounts for a small percentage of producers because of the limitations placed upon it. However, under well-managed systems, crawfish yields can approach that of a well-managed single-crop system. The second and more common multi-cropping approach involves field rotation. In Louisiana, rice farms are normally composed of several fields managed independently, with some fields always out of rice production in a given year. Rice is not typically cultivated in the same field during consecutive years to aid in the control of weeds and diseases. As with the rice-crawfish-rice rotation scenario, crawfish culture follows the rice cultivation in the field rotation approach. Therefore, crawfish production does not occur in the same field in consecutive years. Rice is typically planted in early spring for greatest yields. When the crop reaches a height of about 12 to 16 inches, broodstock are introduced into the growing rice crop at low densities of about 40 to 60 pounds per acre. Stock may come from a neighboring field, often separated by a road or a levee, or purchased from outside sources. These adult crawfish will eventually burrow into the levees around the field and will not affect rice yields. The field will be drained and rice harvest will occur in August while the crawfish are safely burrowed. The field might be irrigated or flooded lightly to encourage regrowth of forage that will serve as the food resource for growing crawfish. Since these fields would not have been in production the previous year and flood dates are later than for single crop ponds, few crawfish reach harvestable size until February or early March. Harvesting is delayed when compared to other production approaches where crawfish are reared in the same location each year. However, because the field will remain fallow during the summer or accommodate a late soybean crop following the crawfish harvest, harvesting can proceed much longer than with the rice-crawfish-rice approach. A field rotational approach, while requiring more total land area, ensures more precise management of each crop. The next rice crop will be planted at the optimum time, typically while crawfish harvest is ongoing in an adjacent field. When soybeans are included in the rotation following crawfish, 3 crops can be realized in 2 years. This approach is based on sufficient land resources to allow staggered crops in different fields within a farm and is the preferred cropping system for the larger commercial farms. The advantages of this system over rice-crawfish-rice rotation within the same field continuously are that each crop can be better managed and the crawfish season can be extended. By rotating physical locations each year, overpopulation is rarely a problem, and crawfish are usually larger because of low densities. Crawfish yields under this management approach are generally not as high as single crop systems or well-managed rice-crawfish-rice systems. However, with proper management, yields can exceed 800 pounds per acre of large, high-value crawfish. Other disadvantages of this production system include the need to restock each year, and the bulk of the harvest season coincides with declines in market price due to a more abundant supply of crawfish. Groundwater and surface water are used in pond culture, and either is satisfactory provided the quality and quantity are acceptable. Groundwater is preferred because of the absence of predatory fish, and it is less likely to contain pesticides or industrial residues. However, higher pumping costs are associated with groundwater and at times may be low in dissolved oxygen and high in hydrogen sulfide, but adequate aeration can rectify this problem. Surface water is usually cheaper but less dependable in quantity and quality and must be screened for fish. Pond depth ranges from 10 inches to 2 feet or more. Factors influencing depth include levee capacity, pond bottom grade, forage type, trap design, and personal preference. Water requirements vary over the season depending on evaporation and rainfall patterns. But 2 to 5 acre-feet per surface acre of pumping capacity is commonly needed each season. Water quality requirements for crawfish are similar to other aquatic species. Crawfish are more tolerant to low dissolved oxygen levels, which is very hard to manage in forage-based systems. Mechanical aeration is not widely used. Water exchange or flushing has been a management tool for increasing dissolved oxygen content, but the elevated price of energy and unproven utility of this practice has discouraged its use in recent years, except in extreme cases. Management is relegated to optimizing flood dates to take advantage of cooler weather and slower decomposition rates, and to shallow initial food depths to minimize the exposure of vegetation subject to decomposition. Heavy vegetative cover encompassing the pond area limits the harvesting options in crawfish aquaculture. Seine harvesting, a common method for many aquaculture species, doesn't work for crawfish. Instead, the crawfish industry relies on baited traps. The shallow nature of farm ponds allows the use of the pyramid trap. This trap is a wire mesh trap and gets its name from its shape. The trap is positioned upright in the pond with the top extending above water. The top is open to permit rapid removal of crawfish and rebaiting. A retainer collar at the top prevents crawfish from escaping through the top and serves as a handle. The size and shape of the mesh wire used to construct the trap governs the size of crawfish caught. Most traps are made of 3/4 or 7/8 inch plastic-coated square mesh wire. These mesh sizes prevent capture of undersized crawfish. Traps are most effective when distributed throughout the pond and are normally set in rows to accommodate harvest by boat. Most ponds larger than 4 acres are harvested with the aid of a motorized flat-bottom boat designed for shallow water propulsion. Several boat types and propulsion designs are available. The most common consists of an aluminum boat equipped with a hydraulically driven metal wheel that extends beyond the boat and either pushes or pulls the boat through the pond. A gas engine inside the boat powers the hydraulic system for propelling and steering the boat. The boat travels down the lane of traps. Traps are emptied and rebaited from one side of the boat, often without stopping at the traps. Producers use 10 to 20 traps per acre. Harvesting begins as soon as the catch can be justified based on catch efficiency and market prices, usually several months after flooding. Trapping frequency varies with catch efficiency and marketing conditions, but traps are typically emptied 2 to 6 days per week for 3 to 8 months. Catch efficiency is determined by many factors, but rarely exceeds 2 pounds per trap per day on a sustained basis. 1/2 pound to a pound per trap is more common. 2 categories of bait are used to attract crawfish. Natural baits of fish such as shad, pogie, or carp are commonly used when temperatures are below 70 degrees. Though fish bait is much more expensive and requires cold storage, it is still the most cost-effective bait for cool water. Producers will quickly switch to formulated or manufactured baits when water's warm. These pellet-type baits are made mostly of grain and do not require additional handling or refrigerated storage. Most baiting regimes are based on a 24-hour trap set, but in cooler water, 48-hour or longer sets are sometimes used. Occasionally, when waters are warm and harvest is near peak, a 12-hour set may be used. Harvesting is the most labor-intensive part of crawfish farming, and typically 50% to 70% of their total direct expenses are associated with harvesting. Bait and labor required for trapping are the greatest expenses. The minimum acceptable size for individual crawfish in food markets varies with season, abundance, and price. Preferences are for crawfish larger than 25 count to the pound. Size achievable for pond-reared crawfish is dictated largely by environmental conditions rather than age. Crowding slows growth, often causing crawfish to mature at smaller sizes. Crawfish are very aggressive, and those with large claws tend to intimidate, outcompete, and cannibalize smaller individuals. To achieve high yields in commercial production, crawfish must be harvested soon after reaching acceptable market size. This removes larger individuals from the population, leaving room and food resources for undersized animals and lessens the domination factor. Crawfish catch from production ponds is dependent mainly on water temperature and density of marketable crawfish, but the catch can vary 2 to 3-fold from day to day and is influenced by many factors. Weather events, bait type and quality, and molting patterns of crawfish play a role in the variation of the daily catch. The daily yield of crawfish from aquaculture ponds is also highly seasonal, with the peak occurring from March through June. Fortunately, the peak production of crawfish in Louisiana coincides with peak demand. Most of the domestic supply is consumed in Louisiana and surrounding southern states, in particularly Texas and along the coast of Mississippi, Alabama, and Florida. Crawfish are initially marketed live for farmers, and a large portion of final sales to consumers are for live crawfish. Live crawfish demands the highest prices, with the largest animals bringing the premium prices. Producers of large crawfish have a competitive advantage, especially when the supply of crawfish exceeds demand. Most producers sell live crawfish to a primary wholesaler or processor, although a limited supply is sold directly to retail stores, restaurants, and consumers. Highest demand by consumers and restaurants is on weekends, with limited retail sales early in the week. The live product, with its restricted shelf life of no more than several days, largely dictates harvesting schedules and market plans. Shelf life also effectively limits regional and national distribution. Whether served in households or retail outlets, live crawfish are typically boiled and consumed hot and fresh in a festive atmosphere. Crawfish boils are generally associated with social occasions, and no food exemplifies the Cajun cultural atmosphere like boiled crawfish coupled with spicy vegetables and cold beverages. When crawfish are abundant or when live markets become saturated, a portion of the annual crop is processed and sold as fresh or frozen tail meat. The most popular processed product is cooked, hand-peeled, and deveined meat, which is sold in 12-ounce or 1-pound packages. This package may be packed with or without the yellow liver-like tissue, commonly referred to as the fat. This edible tissue is flavorful and an important condiment in Louisiana cuisine. The processed meat yield for cooked crawfish is about 15% of live weight. Immature crawfish yield 4 to 5% more meat than mature individuals because they have smaller claws and thinner shells. Cooking time and peeling technique can also influence meat yield because all processing is by hand. Crawfish meat is used in many ways and can substitute in many shrimp recipes. The amount of crawfish processed for tail meat in Louisiana varies annually, but since the introduction of inexpensive crawfish meat from China, less than 10% of the annual crop is now processed for meat. Another product form is cooked whole crawfish, usually served fresh and hot. Traditionally, crawfish in the southern U.S. are cooked with red pepper-based spices and seasonings, often with onions, potatoes, and corn that complement the meal. The consumer extracts the edible portions of the crawfish by hand. Increasingly popular in Louisiana and within the range of delivery for live crawfish outside of Louisiana are retail outlets and restaurants serving hot boiled crawfish. Small seasonally operated takeout outlets have developed wherever live crawfish can be readily obtained, and many businesses also cater boiled crawfish to large groups, parties, and festivals using custom boiling rigs. Grading by size is usually not practiced early in the production season when supply is low and demand is high for crawfish of all sizes. But as the volume of crawfish increases in early spring, size grading becomes a standard practice for servicing the market demand for large crawfish. Nearly all grading occurs at wholesale outlets or processing plants using modified vegetable graders or custom-made graders. Currently, no uniform size or grade standards exist for crawfish, as with other seafoods, hindering market development and expansion. But based on a number of production and marketing conditions, crawfish are typically graded into 3 classes. Larger crawfish are sold to restaurants, with the smallest being processed for meat or blended with larger individuals for large volume sales. Marketing of domestically produced crawfish has been complicated in recent years by imports of crawfish products. Nearly 16 million pounds of imported frozen processed meat and whole boiled crawfish, mostly from China, are brought into the United States. Although an anti-dumping tariff has been imposed by the U.S. Department of Commerce on much of the imported crawfish meat, damage to the U.S. processing industry has occurred, with nearly a 90% reduction in processing capacity in Louisiana. As a consequence, each year thousands of tons of smaller crawfish are not harvested for the lack of adequate live markets and processing infrastructure. Although demand for crawfish in Louisiana is high and markets are expanding in adjacent states, crawfish are in direct competition with products such as shrimp, prawns, lobsters, and crabs. Because of restricted geographical areas of production, seasonal supply, unstable prices, and cultural wars, crawfish sales nationally have been limited, but have increased in recent years, assisted by the foreign imports of frozen products. Supply and demand relationships are reflected in price variations from year to year and week to week during the harvest. Prices are highest in winter and early spring when supply is relatively low. Prices usually decline significantly in late spring and summer when supplies peak and demand for other locally produced seafood such as shrimp and crabs increases. In Louisiana, prices decline from 40 to 55% for field-run crawfish within several weeks during peak production if crawfish size decreases. But the price drop for larger crawfish is substantially less. In some instances, large crawfish command a wholesale price 2 to 3 times higher than medium or small crawfish. As a rule of thumb, the wholesale price for a pound of crawfish meat is 10 to 12 times higher than the wholesale price of a pound of live crawfish. To provide a more appealing product for live market, a small number of producers have adopted the practice of purging crawfish before selling them. Crawfish are confined in water or very humid conditions where food is withheld for 12 to 24 hours. This process cleans away mud and debris and eliminates or reduces digesta in the intestine, which consumers find unappealing. This method should not be confused with the practice of immersing crawfish in salt water immediately before boiling, which is not effective in evacuating the gut and is little more than an external wash. To encourage purging, crawfish are held in raceways or tanks within specially constructed boxes or baskets that are usually suspended in water. Equally effective but seldom used is a water spray system where crawfish are held in shallow pools of water under a constant spray or mist. Holding crawfish in aerated vats or purging systems under crowded conditions for more than 24 hours is not recommended because of the possibility of excessive mortality. Though purging increases the cost of the product, purged crawfish have higher consumer acceptance, particularly outside of traditional markets. Some people who have eaten crawfish for many years are accustomed to non-purged crawfish and do not find them objectionable, although many prefer purged if the cost was reasonable. The abrasive action of crawfish together during purging effectively polishes the shells. However, for non-purged animals and excessively stained batches of crawfish, processors may do further cleaning. External cleaning of live crawfish with ascorbic or citric acid and baking soda is becoming increasingly common. Crawfish are stored and transported in plastic mesh sacks. Sacks hold between 35 to 45 pounds of crawfish. This method is preferred over rigid containers such as totes because crawfish can be packed in a manner that prevents damage from claws, which can happen when animals are not sufficiently restricted. Sacks should not be packed too tightly to minimize crushing, but enough to restrict movement. Sacks of live crawfish can be transported in open bed trucks for short distances. However, wholesalers who haul live crawfish over long distances or large quantities do so in insulated trucks. Crushed ice is placed over the sacks in non-refrigerated trucks and in some cases, refrigerated trucks to reduce crawfish metabolism and maintain a high level of humidity which increases the shelf life of live crawfish. High survival during transport and storage begins by ensuring crawfish are handled properly and harvested from ponds with good water quality. Crawfish should be transported to on-the-farm coolers or to market as soon after harvest as possible and protected from excessive wind and bright sunlight. Sacks should not be stacked so high that crawfish on the bottom are crushed. Sacks of live crawfish in good physiological condition can be held in high humidity coolers at 38 to 46 degrees for up to several days prior to peeling or consumption. Gill moisture is crucial for survival of crawfish held in coolers. This is usually accomplished by periodic wetting of the crawfish or placement of wet burlap or ice over the sacks of crawfish. Chilled crawfish can be placed in stackable plastic tote boxes inside the cooler with the top tote filled with ice. Melting ice is allowed to trickle down through the totes to provide the necessary moisture. Placing non-chilled crawfish in totes is not recommended because damage can occur to the crawfish as a result of the claws of the animals. For years, crawfish have been a Louisiana cultural icon. Now it seems much of the Southeast is learning that crawfish are more than just good catfish bait. They contribute to the economy by providing jobs and additional income to farmers at a time of depressed commodity prices. Best of all, crawfish is a delicacy any time of the year, with boiled crawfish being a springtime favorite and the centerpiece of backyard celebrations across Louisiana and maybe one day soon throughout the Southeast and beyond. Species of crawfish dominate the industry: the red swamp crawfish and the white river crawfish. They are often found together in commercial fishery and in culture ponds. The two species have similar ecological and cultural requirements and may be similar in appearance to inexperienced persons. Though the white river crawfish is often lighter in color, sometimes having a whitish appearance, color alone is an unreliable means for distinguishing them. Other key features of the white river species, such as longer, slender claws, lack of a dark pigmented stripe underneath the tail, and a wider gap where the two halves of the carapace meet, are better identifiers. The abundance of each species varies among ponds. However, the red swamp crawfish usually dominates and is preferred in the marketplace. Despite efforts to limit culture to the red swamp species, both are responsive to production methods. Crawfish aquaculture developed around an existing commercial fishery. Early immigrants took advantage of Louisiana's extensive wetlands to harvest game and fish and discovered that crawfish were excellent table fare. Crawfish thrive in the Mississippi floodplain of the Atchafalaya River Basin and are adapted to flooding and drying conditions common in this system. Their abundance and acceptance as a food source led to the commercial fishery industry. However, this fishery is seasonal and corresponds to extended periods of flooding. Harvest is highest in years when high water levels are sustained and low when water levels are low or floods short-lived. Farming practices began modestly in the 1950s. The industry became more commercialized in the 1960s when rice farmers and landowners began to expand with crawfish. Rice farmers have suitable flat land, much of the necessary equipment, and organic residue left over from the rice harvest. Crawfish was a logical choice for a second off-season crop. Because of expanding markets for crawfish and low profits for agronomic crops, land devoted to crawfish grew rapidly until the late 1980s, when it peaked at more than 130,000 acres in Louisiana. Most rice and crawfish farmers regard crawfish culture as a Crawfish production is the largest crustacean aquaculture industry in North America and is located primarily in the southern U.S. The industry focuses raising the animals for human consumption, although some are sold as fish bait, for aquariums, or for research. But the bulk of the industry is geared toward producing food for people. The culture of crawfish evolved primarily in Louisiana, and that state continues to dominate the industry in both culture and capture fisheries, with total annual yields of about 80 million pounds. Crawfish are also grown in several other states, including Texas, Arkansas, Mississippi, and in both North and South Carolina. Two species In Louisiana, crawfish are caught, cooked, cleaned, and of course consumed. Crawfish contribute to the economy through job opportunities, farm income, and wholesale and retail sales. Now through marketing campaigns, crawfish are being enjoyed outside of their traditional marketplace with the opportunity for further expansion. With all of this going for crawfish, it's time to celebrate Louisiana's culinary crustacean.